Hi, I'm showing how to conduct this DNA-peptide conjugate reaction and DNA protein cross-link reaction, which is by the reductive amination, and then also after that I'm going to show the DNA protein cross-link formation and the DNA peptide conjugation by the oxime ligation. And then I can also talk about the DPC formation of 7D as a dihydroxypropyl containing DNA with a protein as well as a peptide. To start the reaction, I calculated the concentrations here. I am using 500 picomole of DNA, which contains 5-formyl DC at one of its sites. So DNA to peptide ratio is like always 1:100. We observed that the reaction yields are better when you use the 100 equivalents of peptide compared to the DNA. So I am using 500 picomole of DNA and then 100 equivalents of that is 50 nanomole of peptide, and then I am using 5 millimolar sodium phosphate buffer with a pH 7.2. So the DNA is 2 microliter and then the peptide is 5 microliter, and then I am adding 3 microliter of water to that, which brings it to 10 microliter, and then I add 10 millimolar phosphate buffer to that, 10 microliter, so which brings the concentration of this thing to 5 millimolar of the buffer at final concentration. To start the reactions, I take a 10 microliter of this phosphate buffer. Then to this I am adding 2 microliter of DNA, two microliter of DNA stock solution, which is like equivalent to 500 picomole to that, and I am adding 5 microliter of peptide, which is 100 equivalents. And to make up that I am adding 3 microliters of water. So the final total value for this reaction mixture is 20 microliters. After that I will mix it properly. This reaction should be conducted at 37 degree. I am putting this switch on the heat bath, the DNA, peptide and the buffer. So I mixed it properly and then I am putting it at 37 degree. So this reaction should be done for 3 hours at 37 degree. This reaction is running at 37 degree for close to 3 hours now. So the next step of this reaction is we have to add the 50 millimolar sodium cyanoborohydrate to the reaction mixture to stabilize the skip bases. So I am taking this like reaction mixture out, and then to that I am adding 5 microliters of sodium cyanoborohydrate, and then I mix it properly, and then after that you again put it at 37 degree overnight. So the reaction should be running at 37 degree for close to 16 hours, and then we can continue the reaction next time. So after performing the reaction overnight at 37 degree for this reductive amination for the construction of DNA peptide conjugates, here the unmodified peptide which has normal lysines and arginines into that. So after this, the reaction mixture was dried on a spade vac, and then after drying, so the whole reaction mixture was reconstituted in water. So then there are two ways to purify this DNA peptide conjugates, one either by the gel electrophoresis or by the HPLC. So in my cases I always use HPLC, where you use a synergy hydro-RP column and then you use the 100 millimolar triethylammonium acetate buffer with the pH 7 and acetonitrile to purify this DNA peptide conjugates from the reaction mixture. The second alternative method is gel electrophoresis. So in the gel electrophoresis, you reconstitute the compound in water and then you load it onto the 20% page, and then you run the page at around 200 volts for 2 to 3 hours, and then cut the DPC band and then extract the DPC from the gel. My preferred method of purification is always HPLC, which is much cleaner, and then also you will minimize the loss of product, which by gel you can always get 20 to 30% of the DNA peptide conjugate extracted, but whereas by the HPLC you don't see any loss of your product. To purify the DNA peptide conjugate, I always prefer the HPLC method. After the purification of the DPCs or the DNA peptide conjugates from the HPLC, so then we desalt these DNA peptide conjugates by the NAP5 columns. So after the desalting, check the concentration of these DNA peptide conjugates by the nanodrop, and then use around 10 to 20 picomole of this DNA peptide conjugates for the mass spec characterization. For the mass spec, we will use the Zorbax SV300 column, and then 15 millimolar ammonium acetate buffer and acetonitrile as buffers. So then the mass specs are run in the negative mode. So then where you see the molecular, the charge states which corresponds to the DNA peptide conjugates.